Right? Okay, fine. So finally, we are talking about a new special function and what we call this as a filter. What is this filter does here? Generally, what filter does is it is used to filter values based on some condition on a sequence of elements. That is what filter does here, friends. So, for example, that is what I am explaining, how the nature of how filter function behaves. So what filter does, we have some sequence of elements like this. That sequence can be a list or it can be a tuple. It can be anything. Like sequence in sense, something a linear data structures. Right. So it can be a list or tuple. That is fine. Now we have a filter here. And then now what do? We apply some conditions. Suppose there are even and odd numbers in this. A simple example to understand filter. So what do we have here? Even and odd numbers. We apply a filter and filter, right? We apply a filter function and filter all even numbers, or we filter all odd numbers based on this condition check. And instead of applying on one specific element, we would like to apply on all elements one by one. So in such case, this filter function is one of the best choice. And what these functions, these special functions does is they iterate these sequences and apply condition parallelly. Both happens hand in hand. So iterating a sequence happens at the same time. Applying condition on each element happens. Both happens hand in hand. Means both happens parallelly. So that is what this function. That is the speciality of these functions, friends. Right? So let us just see a small example now on filter function. And this is the syntax of filter. What is the syntax? Filter function takes two parameters. One is the function, the other one is the sequence. Function, this is a regular function or lambda. It can be a regular function or a lambda function. This can be anything, friends. It's up to you. If you want, you can create a normal function and pass that function as a parameter. Or else you can pass lambda directly here in one line, in a single line. It's up to you. And sequence means, a list or tuple. You can pass anything like that. So it's up to you, friends. And but this function, this filter takes two parameters here. What does it? It takes two parameters. Hope this is clear, friends. Now, what do we do? Let us implement a simple program to implement this filter function. So what are the important things we need to notice here or observe here? We need to create or prepare two parameters. One, a function, regular or lambda. Two, we need a sequence. Of course, sequence is the first thing, that is the input. And function is something which provides the functionality. And filter is something which applies both and finally gives us some result back. So this is how the the process is applied, friends. You got it right. So this is how this is the behavior of filter here. Hope this is clear. What do we do right now? So we just go and just create a simple program. Let's create a new program here and functions again. We name this as a filter with what shall we say? Filter with regular function. Okay. Let us create a simple program like this. Excuse me, friends. I'm closing all these tabs, friends. Not needed. Confusing. Now, first thing, if we should create a filter, let's see this now. We need two parameters to this filter. One is function. The second one is a sequence. Okay. So now, first thing, what is that? What is that we should do? First, we'll go step by step. Let us create a sequence first. Create a sequence. Okay. And what is that? See, this is so simple, right? Some list equal some L1 equal to that name. You can choose whatever you want, friends. Something like 1, 2, 3, 4, 5. Or if you can choose something bigger as well if you want. Right? This is the sequence we created. Now, on top of this, we need to just apply a function. So how do you apply a function? Simple function. Create a simple function. So def. So we just name this as even check or even or odd check. We can create anything of our choice. So even check, right? And usually when you are applying a filter, it iterates this sequence and passes each one element at a time. So number of parameters to this function should be just a one parameter. So just take one parameter and validate this x here. How do you validate? Simply if x percentile 2 equal to 0, then what do we do? Return x. That's all. So that is what if it is even return this. Else, let us see what happens now. Else return again x only, right? Return x. If it is odd, then return that. Let us just see what would we get on this. Hope this is clear, friends. This is a simple validation. We are just applying through filter function, right? So that's what we are doing here as per the this one. You can see here. So sorry, there is a slight change here, friends. So we need to use Boolean here. Correct. That's correct. Only. Yes, don't return X. If you say true, then those values are added to the resultant, I mean, list or sequence. And if you say false, after validating, even though we come here, it won't add this value to the resultant list or tuple or resultant sequence. In one word, we can use the sequence. So this is the valid logic. Okay. Of course, don't use X or Y. So don't return X because it doesn't make any difference. We get the same list of values. So here, this is how we have to create step two. What is this step two? Creating a function. And this functions is something which is applicable for filter. Here, if it is a regular function, we can just directly print that if X is odd or X is even. But here, we prepared this function in such a way. So this can be passed as a parameter to filter function. So this is the idea, friends. I hope this is clear for you. So what we are doing here, we are validating. See here, we have to return a Boolean value. Don't try to pass any even or anything. Based on this, when you pass this function as a parameter to filter, filter will choose only this even numbers from the list. So which whenever we that Boolean true is present, when it is written as true, that value is added to the sequence, resultant sequence. And if it is false, it won't add that value to the resultant sequence. So who will add that filter thing, right? So based on these booleans, filter chooses which to be added to the resultant sequence or which to be removed from the resultant sequence. If it is true, it will add that result to the resultant sequence. If it is false, it will ignore that result to the result to add it to the resultant sequence. I hope this is clear, friends. If you have any doubts or questions or confusion, please let me know. We'll discuss. But this is the idea. And finally, what we have to do, apply a filter now. Some filter of first thing, we have to say even check. Comma, what is that we should do? And then we have to pass sequence. And we should assign this result to some variable, something like result equal to. And now we should assign this function, sir, not variable. This function caller to some kind of this thing variable, and this acts as a reference to this object, filter object, so that we can have access to the filter object. So now, what do you do? print res. Print that result, friends. I hope this is clear. So now let's run this and see what do we get. But did you get the steps? This is step 3. What is step 3 here? Step 3 is applying filter. So we follow same for almost all. These steps are similar for all these special functions. Like map, we have to create same. We have to create a sequence and prepare a function and pass those two parameters to those two values as parameters to map function. Similarly, we are doing same for filter, but the behavior and the usage is different here. For map, the usage is different. For filter, the usage is different. You can see there is a slight difference here. So now when you run this, let us see what would be our output here. Right. So right click and then run this. And you can see we got a filter object. And when you get a filter object, if you are very new, we might think something is wrong, but there is nothing wrong here. Everything is quite fine, and we are doing fine. But the only thing is when you see some objects like this, these are all special objects again. This filter object, map object, or reduce object. These are all special objects. Okay, internally you have your resultant, your resultant sequence. This filter holds or preserves your result. Now you should iterate this to view your resultant output. Okay, if you want to view that result from this filter, then you should iterate this. That is what we should do. And to avoid this, the another best practice is typecasting it to some viewable collection like list or tuple or something. Suppose if you just see apply a typecasting to this some list here. See here, friends. We are applying a typecasting to list here. Right click and then run this. Now you can see the output here. These are even numbers, and we are pretty well able to see that even numbers. So now we are not seeing any filter object. Why? That filter object is converted to list, and that is written as that is assigned to this reference variable res. So when we print that res, we are able to see that values that is filtered by filter function. Right? That is this is the best practice. What is the other way you can iterate that filter? Maybe let me just show you that as well. This is case 1. Already we had discussed a similar one yesterday, but anyhow, let us go clearly step by step. So when we run like this, what happens? We just get a simple filter object. Now apply an iterator on this for I in res colon and then print off what I. Now we can see all the values that are present in the filter. If you just iterate that filter object that is returned through this variable res. Now run this and see. You can see here we are able to print 2 and 4 from this filter object. Right, friends? So now what do we do again? So case 2, we can simplify this. The best practice is this one. What is this one? Just convert it to list, friends. Convert it to list. Apply a casting to list so that we don't need to do this extra operation. This is not needed. This adding iteration to that filter is not needed if you just typecast to the list. Okay. At least to view that result. Of course, if you want to do any processing on list, we need to iterate list, no doubt about it. Okay. So right click and then see. And this time we can see two different approaches. One, in the first case, we got this raw object filter and we applied some iteration on that, and we are able to view results from the filter object. That is case 1. In case 2, we applied a typecasting in the case 2 here to list so that values, whatever the resultant values that are acquired after applying this filter function, those are converted to list, and they are written back in the form of list here. So that's what happens here. right? So this is a simple idea, friends. I hope you are clear with the right this second approach as well. So it's up to you which one to choose, but we have two approaches to deal with this filter function. So you can choose whatever you want, friends. Right? That's the idea about filter. We are done with this one approach of filter, that is using filter with regular functions. The same thing we can rewrite with lambda, and that is much more simpler. When you look at if you are fine tuning this with lambda, you come up with a simple statement that this is so simpler than using regular function Manoram. Definitely. Lambda just simplifies all this because we just create everything in a single line. We can see how much lines of code are there when we are using a regular function. But if you rewrite the same with lambda, you can see many of these lines are cut down, cut short. So that is much more simpler approach. Okay. So what do we do, friends? Before I jump to approach two with filter. This is approach one. What in this approach, what we are doing, we are using a regular function as a parameter and applying this filter on this regular function and sequence. So this is one approach. So before I jump to the lambda scenario, could you please confirm you are clear with this approach, friends? Or in the chat box, please, let me know if you are clear on this. Are you clear? I think Harish and I think we have few this thing I can call with names, no problem. Balaji and Sunita. Are you good with this? Please let me know. Please answer in chat box if possible. Okay. Thank you. Next one. Let us create one more. Let us jump to another approach. So what is this? This is approach one. What we are doing? We are creating filter with regular function. Second one, update again, creating filter with lambda. That is second approach. Let us just create. I think we had a very clear discussion on this, friends. Let us try to new Python file. Next one, filter with lambda function. Okay. So what do we do right now? Same thing. Just you can copy the sequence. These steps are same. First, we have to create step one, create a sequence. But this time we don't need to create a separate function like we did in approach one. What we do first, this is important. Also, I'll add this comment as well, just for, okay, let's have this and approach two. We are simplifying same filter with lambda function. So what do we do right now? So we are applying a filter function with two parameters. So this is fine. These two parameters are fine, friends. And now what is that we do? We created a sequence. Second, we don't need to create separately a regular function like regular function. So just we can directly apply filter and then what do we do? We apply lambda, 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 and then parameter. Just you can take one parameter colon x percentile 2 equal to 0. This time you don't need to return any true or false. Based on that condition, lambda will automatically filter element and then add it to the resultant sequence of filter. And then this one, right? So this is rewriting our previous program with fine tuning our previous program with lambda. Now you see this program, see here, you see this program and you see this one. Which one is much more simplified? The second approach is very simple, right? If you understand lambda, we don't have any big issue with this filter. Just having that clear idea about lambda is very important. That we had a very detailed discussion yesterday. So how to create a simple lambda function, anonymous, just lambda keyword, and then argument first, and then your logic later. So that's it. So what do we do right now? First, let us assign this filter to some variable, and maybe we can print it directly, print out that result, and then let us see what would be the output. We got a filter object here. And in this case, again, what we should do, if you get a filter object, we are not doing any casting, right? The best practice is applying casting to the filter so that it will automatically convert this filter object into that required type. If you are casting with list, then filter object is converted to list. If you are casting with tuple, filter object gets converted to tuple. But for now, we are not applying any casting or conversion. We are just getting that filter object as is, that resultant filter object as is. So, and we are assigning to this reference variable res. So what do we do? In that case, we can simply what we do for I in simply that result. We can just print that I here, friends, right? And then right click and then print it. You can see here 2 and 4. Is this clear now? So that is same thing. We got same output, but with a different approach. We just simplified our previous approach with the lambda in this scenario. Right. So this is approach one. So what is the approach two again? So case two is you can just apply a small conversion to this. So to avoid printing and all that, a straightforward process. Of course, if you want to get element by element from a list, again we have to do iteration. That is important. So now you can convert this filter to list or tuple or convert this to list to any of your required sequence friends. So right click and then just run this now. You can see output now here for case 2 as well. Okay, so this is how we can play with this. What is it, friends? This filter function. Hope this is clear for all of you, friends. So we have to do the conversion, and if you print it this time, you can view this list here. Maybe if you want to convert it to tuple, you can do that as well. So what you can do, just pass tuple as your conversion method so that you get the output in the form of what, friends? In the form of tuple, you can see there. It's up to you what should be your conversion mechanism. What kind of conversion approach you should follow, you can decide, friends. But I try to show you. If you want, you can convert this to set as well if you want. See. Sorry. You can see we can convert the result to set as well. It's up to us, friends, to what viewable collection. Viewable means where we can see the results. Collection we can convert, that we can decide. Developer can decide, friends. I hope this is clear for all of you, right? So this is the idea about filter with both approaches. Filter function, which to which we passed regular function as parameter. A filter with the lambda as parameter. We tried to see both scenarios and we had a very clear discussion on this. Hope. Shall we switch to the next topic? Before I switch, can you please confirm in the chat if you are clear with this discussion or any confusion on this points? Are you good with this? Right. Thank you. So what do we do? Let's move to the next topic, friends. What is it? And finally, reduce. Reduce is simple, right? Name says reduce. Reduce function. What is this reduce function here? It is used to reduce some group. See, simply speaking, if you have some group of elements, all the group of elements are converted into a single element. So what? This is simple. Reduce is used to reduce sequence of element into a single element by applying the specified function. Suppose you have multiple elements like this, something like 1, 2, 3, 4, 5. Now you want to convert all this into a single element. Suppose we want to do sum of all these elements and just get this result. That's all. So sum means what? How many values do we get after doing addition on all these elements? We just get one value, that is 15. That's all. You see now. So this is the input for reduce, and this would be the output from reduce. Like in the previous two cases, like previous two examples, like map and filter, we don't get multiple values as output, right? We just get, if we give groups a sequence as input, we get a single element as output. That's all, friends. That's all, friends. And this is the behavior of reduce function. I hope this is clear for all of you. Right? What reduce does? It is used to reduce sequence of elements into a single element by applying the specified condition. That is what happening, right? This is the input and this is the output. Right. So again, other things are almost same now. Now it will be much more easier for you to understand the syntax and everything. Again, reduce takes two parameters like function and sequence as usual. It can be a regular function or a lambda function. It can be any one of these two, friends. It's up to us if you want to pass a regular function as parameter here, or if you want to choose lambda as a parameter directly here. It's up to us. Okay, but these are the two approaches we can follow. So that is the idea about syntax, friends. Right? Now the other two functions, map and filter, we are able to use it directly in our Python because that is available directly. Though that those functions are directly available to the developer. So they are not part of we don't need to import any libraries if you want to use map and that filter functions. But reduce is a little special here, and this reduce function is available in this library function tools. What it means. So if this reduce is available in some kind of library like this, then what is that we should do? We have to import such kind of libraries. We cannot directly use this reduce function without importing this module. This is called module or library. So what do we do right now? So see here, this is simple thing. We can't use reduce directly like how we did for map and filter. What is that we should do? Here, reduce is available in a module called functors. So what should we do in such case? We have to import this module in our code. Then we can use reduce here in the code. So, what is that we have to do now? Import this functors. Simply, how do you import it means? This module, it is a simple thing. You can simply say from functors import asterisk or import functors. It's up to you. If you want to go with asterisk or if you want to choose, sorry, not import functors, import reduce. Okay. So if you want to choose reduce or if you want to apply asterisk, it's up to us, friends. But this is the approach if you want to use a module of some library in Python. We have to import such modules. If some functions or some classes or some methods, if they are part of some libraries, and if you want to use it in your program, then we should import such modules. And that can be done in two ways. So this is one kind of import. From import, what we call. There is another import, normal import, that we'll see when we discuss modules topic. Maybe after this, we'll discuss modules only, right? Once we complete this session, we will pitch into the next topic. We'll step into the modules. So that is also very important to understand. But before that, is this clear now? So finally, what is the conclusion? Reduce is not directly available for us. It is there in this particular module functors. So we should import it. And here we are using a special import called from import. And we should say from functors, from this module, we are saying import reduce. That's the meaning of this. Asterisk means import everything. And among all that reduce is there. So we are trying to use reduce. That's it. So among all those methods or objects that are there in import, we are choosing this reduce function. That's enough. We don't need, when we say asterisk, it's not needed to use all those that are imported to our code. We can just choose which one we want to use, like going to a buffet. There might be a number of items. It's not like you should eat all items. You can choose which one you want to eat. Even this is like this. When you say import asterisk, all those objects that are present in that module are imported to our code, but we can choose which one to use here. I hope this is clear. I'm trying to be very clear so that you don't have a confusion here, friends. Okay, that is fine. I believe with this discussion, you are very clear on these things, like, what is this reduce and where, in which module that is present, and how to import that to our code, and what is the from import. This is a simple kind of import which can be used to import objects that are there in some module. We'll talk more on this when we discuss modules topic, friends. Okay, that is the idea. Finally, we understood whatever that is needed to get starting with this reduce program. Okay, so now let us jump to our as usual business. Let's get to our BAU now. So what do you do? BAU means business as usual, our regular discussion. So if you want to work with reduce, again, what is that we should do? We have to prepare these two parameters. One is sequence, the second one is a function. And here, what we are doing here, we need to do some kind of reduction. Reduction means what? All these five elements should be converted to a single element. I hope this is clear. Excuse me, friends. For that, we can create a simple regular function here. So we generally do from for all these functions like map and filter and reduce, we are following two approaches. Okay, approach one, we are creating a regular function and passing it to that particular special function. Second, we are also fine tuning it with lambda. So let us just jump start with this regular function. So what are the parameters we should pass here? Sequence that we can create. We don't have a big issue. But the second one is what? Creating this regular function. What we are doing here, this code C equal to A plus B, A equal to B, B equal to C. What is this? This is something like creating a Fibonacci series in a simple way. And this simple code, what it does? Simple code, what it does? It just try to reduce all these five values into a single value. That is what this code is doing, friends. And now we can pass these two values to reduce function. So you can see here, first we can pass this function as parameter to reduce and then filter as parameter to reduce. Okay, why don't we just test it now? So we'll go one by one. First thing here is we have to use this in the code. Open this. Let's create a new function here, Python file. And this is reduce, right? Reduce with the regular function, approach one. The title itself says what we are doing with reduce. Okay. So now in this, what we should do? So simply reduce with a normal function, regular function. Step one is you can create a sequence, that is step one. Step two. So what is that sequence? Anything, just some L1 equal to some group of items, 1, 2, 3, 4, 5, or you can choose whatever you want. It's up to your friends. So this is step one. But before that, what is that we should do? So we should import that. What is that from? What is the module that is there that is needed here? If you want to import reduce, you can see from functools. Import. There are different ways. We can say asterisk or we can directly say reduce. It's up to us. The best approach is choosing whichever function you want to import. That is the best recommended approach. Instead of saying asterisk. Asterisk is not a best approach. When you put asterisk, all methods are imported to your code or all objects are imported to your code that are present in this module. And that is not a good practice. It's a bad practice. So in this case, of course, if you can use it like this, so there is no harm in that. But performance wise, it is not a good practice. But still, it's fine. It's we can for for learning that won't be a big issue. So I am choosing directly reduce instead of asterisk. So I want to follow this, okay? But we are also having a clear idea. If you want, we can choose asterisk as well. Just remember, right? This is fine now. After this, the next one is what, friends? Creating a function. So step two is creating a function. If it is a regular function, diff some, right? Some we just need reduce values. I'm just creating a function like this. And here I believe we should take two parameters, right? A, B, right? So this is the one. Now C equal to A plus B, A equal to B, right, and B equal to C. So this is what we should do for it. This is the logic, right? Yes. And finally, we should say return C. That's our friends. This is step two, creating a regular function. So, and this is what we are doing, simply doing addition and then doing some flipping, change, I mean, shifting of values. Generally, this is something like your Fibonacci series. Okay. So that's the idea, friends. Hope this is clear. So what do we do right now? So we have to now, once we prepare this function, we should call reduce. How do you call now? Simply some result equal to reduce of what is that we should do? We should pass function as parameter and then comma this sequence as parameter. These two. And now print your result. Hope this is clear. Right, friends? Print the result and now run this. You can see here we got the total output here 15. Right. This is the simple idea about reduce, friends. We are passing group of elements and those elements are reduced to a single element as output. This is the input and this is the output. Hope this is clear for all of you. And in this approach, in this with reduce, I think we don't need any conversion because we are getting output directly. And this is not writing any reduce object here. We are getting result directly when we assign this reduce to some variable. So no conversion is required here. Like in previous two cases for map and filter, we did convert those functions to list or tuple to view the output that is there in that. But for reduce, we don't need that practice. That is not needed. I hope this is clear for all of you friends. So this is the idea about reduce. Now finally, right? So that's, can you please confirm if you are good with this, friends? Are you good with all this here about this list, map, filter, and reduce? Are you clear on all the special functions in our Python? Right. This is a simple idea you can see here. So we are able to get a clear picture about map as well as filter as well as reduce. So that is the idea. Then what we do, these are all simple things. I think if you want, we can discuss quickly. Okay. So after this, the next topic, what we are going to discuss here is it's nothing but function aliasing. Okay. We are able to complete discussion on the very important functions in Python. You can see here. So what are those functions? We are able to complete with this one, Lambda as well as map, filter, and reduce. So these are very important use cases. Practice well on this. You will definitely expect some interview questions on these things. I believe your interview doesn't complete without questions on these, friends. Just remember. Okay, this is fine. Next one after this is function aliasing. What is it? It is a very simple scenario. You can see we are jumping to the next topic, friends. What is that we do? We just create another alias name to your function. So this is a simple function. By now we are very much into these functions. So you are familiar with all these things. This is a very simple program. What we are doing here, we're just creating an alternate name to these functions. So that so this function as acts as a new reference to the old one. Means this function is having two references. Even if you remove one reference, still another reference will be there pointing to that function object. And that is nothing but what we call function aliasing. So what is it? We can give another name, which is nothing but what we call function aliasing. How do we give that name? See, this is how we do that. And now let us just quickly test this code here. Maybe we can directly test it. For this, you don't need to copy and paste. So what is that here? Python file function aliasing. Okay, and then enter here. Now close this. What do we do right now? First thing, create a function, something, anything of your choice, some text or something. And here take one parameter, some name or something, anything. It's not it's a it can be anything, friends. It's not necessary to be test. Okay, you can choose any of this and then just print that parameter. So what is that parameter? The name is, you can use this placeholder this time and then format and you can pass name here. That's all. Now, what do we do? Just this is a function we created. We want to create another alias to this function. Simply, how do you create some t1 equal to test? Now, what happens here? This function object has two references. What are those two references? One is test, the other one is t1. Now you can call your function either with a test or either with a t1. You can choose any of these two function names. Now t1 also acts as a function name for you. Maybe if you want, you can test it and see the output. So what do we do right now? One approach is calling test by passing a simple parameter, something like John. Okay, so this is case one. And case two, we can also call this test function with t1. It is not needed to call with test because we have an alias this time in the form of t1 here. So t1 of what, friends? You can create something like, what is that we should say? John. Right? So right click and run this. Now you can see two outputs, one coming from t1 and one coming through test. You can see here. But from this, you can easily understand t1 also acts as a name to the function. I hope this is clear. This is a simple idea about function aliasing. Suppose you deleted test. See here now. You deleted test now. I just tried to delete test object. And now you can see still we can access that function something like now this time you can see I'm calling with the F1, sorry, T1. So that alias is T1, right? I'm calling same function with T1 now. This is the actual original function name. But what did I do? I deleted this actual original one. The real one I deleted. And still there might be a question now. Can we have access to this test now? This time we don't have any issue. Excuse me, friends. So we don't have any issue now. Why? We have an alias. So even though we deleted test, this should work for us. But anyhow, let us test and see. Right. Let's run this now. Now you can see we have John and we have Peter coming for the other, after deleting test. So this itself is a clear idea. Alias is nothing but alternative name we provide to a function. Even though we delete that any one of these references, either test or T1, still we don't have a problem. We can access that function with the existing one. I mean, which is there. After deleting some function name exists, right? Using that, we can still have access to that function. So this is the idea about what, friends, idea about function aliasing. Hope this is clear. Maybe you can ask a question. Can we try the same with okay, with this test, Manoram? Okay, let us give a try. After deleting, definitely that object gets deleted from memory. I don't think that exists, but we can still preserve that object in T1. So we can have access to this function through T1. That is fine. But test I have. This is already deleted from memory. And if you try to call it again, let us see here. Something like Blake. We are calling Blake here. Test of Blake. But do you think this color will work after doing this deletion? I doubt if this works here, friends. So this color might not work, but still testing it if it is going to work after deleting this. Okay, let us run this and see. And you have an error here without any doubt. Name error, test is not defined. Why this? Because we had deleted this at what? At line 9. After deleting, if you want to call it, it doesn't make any sense, right, friends? So that is the problem here. So that's the quick idea. And we have observed all the pros and cons about this functional aliasing. But this is the topic. It is a very simple and easy topic to understand. Hope this is clear for all of you friends. Right? Can you please confirm that you are clear on this? Right, next one. So these are all same thing. And the another very important topic in functions is decorators. What is it, friends? Function decorators. So we have to discuss again about function decorator here. What is a decorator? Now we are jumping to the next topic, friends. After completing this, what is it, friends? This topic, what we call function aliasing. The next topic is function decorator. It's a very simple and easy topic. Decorator is simple, and this is very important. You need to have some clear idea about decorators. Okay, and this is used very much in your real programming. So what do we do? What is a decorator? Decorator is a function which can take a function as argument. Again, this is also something which takes function as argument and extend its functionality and returns modified function with extended functionality. When I read this, you don't understand anything, no doubt about it. Okay. By reading this definition, it is little confusing, no doubt. Okay, let me just make it simple for you. This is simple, friends. So decorators, what they does is so they acts as a argument to a function. Keep and you can see here what they do. They acts as a argument as a function and extends its functionality without actually modifying that function. Without directly modifying, it tries to do some changes to that function. This still it is confusing again. I know. So let us understand from program. You can easily understand. Right. This is the decorator. Right. We are applying on top of this function f1. And what this decorator is doing, it is taking your function as parameter and making changes to this function f1 and again returning that back with some extended functionality. So here what is happening? What decorator does is without actually touching your function, it will do some changes to your function. And that is what decorator is. I hope this is clear. Let us just understand this with a simple program. So the advantage with decorator is what? We can extend the functionality of a function without actually modifying that function. That is what actually decorator does. Maybe when you observe all this, when you try to get a clear idea about that, and when you see the output, you can easily understand what is that extended functionality. Your function will be as is. It will be like this. You are not doing any changes to this. Your original function stay as is. But on top of that, when you apply decorator, decorator will try to provide some extended functionality where it try to make some changes to your function without actually modifying the original function. Do you get this point? Is this point clear? What decorator does? You have a function and that function is this f1. What decorator does? We don't modify this original function. But who will do that? Decorator will do. Without actually modifying original function, the decorator will do some changes to your function and apply that to your original function. So this is decorator. I hope this is clear. Without actually touching your function, it will make some changes to your function and then update that. Or it will modify some changes to your function. And that is what we call and that functionality we call it as extended functionality. A simple example, friends. Like as name says decorator. Suppose you decorator is like a makeup artist. What makeup artist will do? You know when you go to any makeup artist, what he does? Decorator, just example. Our face will be there as is, but what he does, he or she does, friends. They try to apply some additional things to our face and try to change, modify our face. But your original face will be again when you remove makeup, your face is as is. You don't have a big difference. But after wearing makeup, that is an extended functionality. What happens? There will be change in your face, right? And who is doing that change? Are you doing it for yourself? That is one scenario. But the other scenario is that makeup is done by you by a makeup artist, another person. That another person we can consider as a decorator. That applying that makeup and doing all that difference to your face is done by another person, which is decorator. That makeup to your face is extended functionality. And that functionality is done by whom? Some other person called decorator. And that decorator, that decorator cannot actually change your face. That is the original function. But they can add some functionality to your face, some extended changes to your face. So, and not directly by you, by some other person, what we call decorator. And I try to make sure you understand this clearly. Does this explanation give you clarity, friends, or is it confusing you? So finally, what decorator does, without actually touching your function, it will try to add some functionality on top of your function, and that is called extended functionality. Is this statement clear? Can you please confirm in the chat box, friends? I try to be clear because this is a little confusing. So that I try to explain it again and again so that you don't have a confusion. But finally, you got clarity, right? So this is simple idea. So and this is very important to understand as well. This decorator thing is very important, right? Many people has confusion on decorators. So I try to make sure that you understand it with simple examples. So that is idea. What is the decorator here? We can extend the functionality of a function. This is your actual function. Hello, name, good morning. Hello, some Manoram, good morning, or hello, some John, good morning, or Peter, good morning. But now, apart from this to the same function, we are adding some this thing about the day here, whether it is raining or whether it is sunny or something. So this is an extended one. And who is adding this extended functionality? Decorator, not us, right? So that is the idea. So this is simple. Let's understand this now. This function anyhow, normal function is very simple for us. We'll do one by one, step by step. First, whenever we are working with decorators, first preparing decorator is very important. So what is this decorator doing? Let's copy this and go to the code here. First creating. simple function here. What is it? Decorator. Okay, use case. And then add this here. Now this is a decorator function. This is actually this parameter is your original function parameter. Here we are passing function as argument. What is it? Function as argument, not as a variable as argument. So even though we name anything, so this variable takes a function as argument. That is step one. Now on this function, we make these changes. So now you can see we are creating an inner function on this outer function. And what is this inner is doing? So you can see here, inner, this is taking a parameter name, and on name it is validating. If name is something like Mano, hello Mano, today it's raining. We are adding an extended functionality, right? We are adding this. If name is not Mano, it is just returning that function as is. So this is what this inner function is doing. Just understand, this is so simple. This is a normal function. Like this inner function is simple, regular, like a regular function. It is taking a parameter name and doing validation. Here is it of Mano. I put some Peter. It looks more interesting. Okay. Hello. I'll just add like this, a pillar, and then a placeholder, then format of, then we put name here. This makes more sense. Okay, this is the simple extended code. What this function is doing, you are passing your this one function as parameter. On top of this is applied. Okay. Now what you are doing in the inner function, we are just trying to take a parameter name and validating if name is some person, some Peter, then we are saying hello to him. Else we are returning the actual function as is back, right? The original function as is back, right? So if name is Peter, we return that extended functionality. You can see return inner, so that this is returned. Else what? If name is not Peter, we are returning same function as is. Right. This function is your original function. Keep in mind, friends. So this is a decorator now. So again, I'm just trying to again recap it quickly. So we are just creating a decorator with function as parameter, which is nothing but your original function. But before you apply this decorator to any function, first you should prepare your decorator. And in this decorator, we create a simple functionality in the form of inner function. So we just created an inner function which takes parameter as a name here, but it can be, it's up to you what kind of inner functionality you should create, that you should decide, okay, based on your requirement. But this is the idea. And this is like any other regular function. We are having a parameter name and validating if that guy is Peter, then we are saying hello to him. This is our extended functionality. And if that name is not Peter, we are returning original function as is. So no changes to that. And if you are making some changes to your, if you are having this extended functionality, return that inner function. If you don't have any extended functionality, return that original function as is, which is passed as a parameter. So this is the idea. I hope this is clear. Understood? I don't think there is any difficulty to understand, right? This is the simple idea, friends. So what do we do right now? At step 2, we should just simply create a apply decorator first. So you take a decorator, something like F1, and you take some name to this. Some F1 have some name, right? And you can copy this, right? That's all. And just say, what is that? You can use format method more than this. That makes more sense. Hello, some placeholder, and say good morning. And then here, apply dot format and then pass name here. So this is the idea. Now, see, decorator doesn't directly come into the picture, friends. When you are calling function, you call F1 only. But see how this is going to work, right? This is interesting. Observe carefully. Now you are saying F1 of what is this? First time you pass John here. Let's pass John. Now, okay. Let us understand how this works. Let us forget how this works. But the question is, what would be the output now? So when I pass John, what is passed? What is printed Is it going to print hello, good morning, or hello, something, today it's raining? What do you get now? Are you going to get this extended functionality as output, or something like just simple statement from here itself? What is the output we are going to see? Hello, John, good morning, or hello, Peter, today it's raining. Hello, John, today it's raining. What is it we are going to see? Definitely, in this case, name is John. So when you pass John to this, but before that, what when you immediately call this function, first it will immediately trigger decorator. Let me just put a debugger and trace this step by step so that you have a clear picture about what's happening here. Before I add debugger, what I want is first let's run it and see the output. And still you have a confusion. Again we put debugger and again we go step by step and see what's happening step by step clearly. Right now the output here is simple. Let's run this. You get hello John, good morning. What's happening here? There might be a question from you. Manoram, we are applying decorator. Is it really getting called or not? Means in this case, your parameter is John. Internally, it will call decorator. But what decorator is doing? It is validating here. It is validating if it is name is Peter or not. So if it is Peter, we get extended functionality. But if it is John, it returns the same your original function as is. So this is getting called. Suppose you change call one more time. This time call Peter F1 of something like you say. You just pass Peter. And now run this. Let's run this. Now you can see when we pass Peter, we are calling F1 only. See, we are not calling anything else. You are calling F1. But you are seeing some difference that even in your F1 function, you don't have this hello Peter, today it's raining. Your F1 is having just hello, something good morning. And but now when you just pass Peter, we see a whole different output here in the console. Now what's happening without actually touching this? You can see here, friends. This is very interesting. See, without actually touching this, we are adding an extended functionality F1 here. You can see here. What is that? When I say pass Peter, immediately F1 is calling something. Hello, Peter. Today it's raining. Don't come to office. That office is not there. You can ignore it, friends. But this is getting called. How? But F1 doesn't know that there is some extended functionality on top of it. But still, see, we are making sure that that is being called, and that is possible with what? By using a decorator. Right? That's what makeup artist does, right? If you just close your eyes and sleep for some time, they come make you beautiful. And you doesn't even know that you became beautiful till you watch it in the mirror. Is it correct? I'm just giving a quick mapping to your this code with a real scenario, that's all. But I hope this is clear. Now what's happening here in case 2, what's happening? It is calling some extended functionality. This is this today it's raining is not there in actual function. But this is there coming from the decorator, from the extended functionality. Now what happens here? Suppose again now, okay, Manoram, when you call John, it is calling this one F1. When you call Peter, okay, we got it somehow. This result is coming from the extended this decorator. We are able to understand that. But how this execution flow is happening? Can you show us? This is slightly not. We want this more understand little deeper. Then put a debugger. Let's play with it. Put a debugger and let's understand how this is working. Okay. Now what do you do? Right click and then debug this decorator. 1 minute. It has to go. Okay. Otherwise, what we do? Put a debugger here as well. It's tightly going with the. Sorry, put here otherwise. Okay, now run this now. Maybe I'm placing wrong breakpoints. Yes, we got we got into this debugging, friends. What do we do right now? Now it is at line 13. Let us try to go Now this is a function call, right? If it is a function call while debugging, what is that you should do? Step into. I'm trying to make sure you get a very deeper understanding of this decorators here. Okay. So now what do you do? Step into. When you say step into, to our surprise, it is not going into F1. See, it is directly jumping into the decorator. See this, friends. So that is what happens when you apply. See, how to add a decorator to a function? This is how. At the rate, we use this at the rate and pass that decorator name on top of your function. This is how we should associate a decorator to a function. Or this is how we should add a decorator to a function. Now when we debug it, when I say step into F1, it has to usually it should get inside this F1, but we are not seeing that. What's happening? The controls immediately jump to this decorator, jumped into decorator. That too from decorator it has gone into inner. Directly it took this John to this name inner function here, and this name will be holding John. See here, whatever John you are passing from here, it is passed to your inner function. Your function parameter is passed to this, and from there this inner function extracts this name from your parameter here, that function parameter or function object. You can see here when I put a cursor on that, it is showing this function object. What is that function object? This one. And from this function object, if you see here, from this function object, it is trying to copy name to this inner function. What is that name? You can clearly see we are passing John. That John is being shown here. Now after that, what this inner will do? It will validate. Let us go line by line to get a clear view of this. Okay. So now what should we do? We should go step over. Right. So this validated, right? So this validated. Why? This name is not John. That's why it's not getting into this print. Again, you might get a question. Manoram, why this control is not going into this if block? How it goes into if block? This condition is false, right? Name is not John. Name should be Peter. If your control should get into this print function, right? Or it should if it should get into if block. So that condition is false. So that the it gets skipped, and so it came to the else block. You can see here. Now means no change to original function. So that's why it is returning. This function is nothing but your original only. See here. If you print F1 also, this hash code of your object will be same. This function func here and F1 here both holds the same hash code. For your, if you want to see even that, I'll print and show you. Right, that is fine. Now when you say func of name means it is nothing but as simple as calling F1 only. Why? We are just trying to, what is that? Returning the original function as is without actually calling the extended functionality. Hope this is clear. Now again, what do we do? Now should we call again step over only? We don't need to do step into. That step into should be done only at the beginning of a function call. Once we are in some function, we can go with the step over. Now what happens? See here. The control is immediately returned back to the caller. Now what happens? Now again, you can say step over. By the time you step over, this execution of F1 is called. Now what do we do? Open console. You can see the output from this caller. Line 13 is printed here. Hello, John. Good morning. But you can see a clear picture of this debugging process, friends. You are able to view it like how the control jumps are happening between your original function and decorator and what's happening internally and the execution flow. Now let's see. This is important because this is where our actual extended functionality is applied. Now you are calling F1 again. Is it a function call, method call? Yes. Then you, in this case, you have to say step into. Don't say step over. Otherwise, your control doesn't get into the function. So what is that you should do? You should say step into. Then this time you can see here your function object F1 is passed to this func. From this function object, it copied that name to this inner function copied name. Now this time the name is Peter and it is trying to validate Peter now. Name is, so this is true this time. This validation is successful. Now what should we do? Step over. Now you see this time what's happening here when you say step over, sorry. Now this valid, this condition is true, name is Peter. So it is getting into this print function and then that is returned again. You can see now. Now step over. Now when you say step over, this it will return this inner object. Again, that will get that inner object here. So that result of inner object is returned and it's get printed. You can see here. Right. So when we say return, before that anyhow, when this condition is validated, when it step into that print, by the time itself this gets printed. Once that printing is done, the job of this decorator is done. So we are saying return inner. That inner will return to outer and outer will be coming back to the this color because the business of decorator is completed here. So finally it will come back to the color here. I hope this is clear. By the time the control came back to the caller, you can see the extended functionality that is there in the decorator that got executed. So what's happening here? It is like like an offer for us, like a festival offer or like this. Your function is as is, and on top of that, you have some extended functionality. You can play with both based on type of values you are passing here. So this itself should give you a clear idea how this is working, this decorator, how much useful this decorator is. So what decorator is doing, without actually doing any changes to your original function, you are adding some extended functionality on top of your original function by using something called decorator. Remember this markup scenario, even to just quickly get an idea about this decorator. And once we create decorator, we should add that to your original function on top of that like this by using this @ symbol. And this is how decorator works, friends. So this is very important topic. In people definitely ask interview questions on this decorator. When I go to interviews on Python especially, you can expect a question on decorator. Sometimes they ask you to write a code and this is something little difficult for many people. So that's why I try to stuck here for some time and make sure that this is clear with every way possible, friends. I hope you understood this right. Is this clear now? Can you please confirm in the chat box if you are clear on this? Please confirm this on the chat box, friends, if you are able to understand this or not. Clear or if you are clear means that's fine. Else if any confusion, let me know. We can discuss back. So this is the idea about decorators, one of the very crucial, very important topic in functions. I mean in Python itself. Definitely there are many built-in decorators people use in real programs. Okay, so that's the idea, friends. Next one after this is so we are almost done with functions. We don't have many more. Let's close this and this one topic and complete functions and jump to modules tomorrow. I mean tomorrow in sense next week. Okay, nested functions. What is it? Hope that you are familiar with the decorators, right? So let's just move to the next topic, that is nested functions. This is a very simple topic. I don't have any big complexity or this thing in this. Very straightforward topic. Nested means a function. This is a function. Inside that you declare one more function and that is called nesting. And if you want, you can add one more. It's up to us. So a function inside a function is nothing but nested functions. And you can see here. So this is so simple. Right. You created an outer function and print something. And you created inner function and print something. And if you want, you can return that inner object as well. Okay. Let us try to see how this works for us. Okay. Let's copy this. Then this is a simple program. I don't think we have any confusion on this. So nested functions. Then we just created a simple program outer and printing some from some print here, some statement. And then we created a simple another function inside outer, you can see inner and printing something and returning inner. What happens here? Let us see something like some function equal to. So in one case, we are returning assigning outer to F1. You can see here. So when you directly call outer, what happens? Let us see. We'll test one by one. Now what happens when you call outer? Is it going to call outer function, or is it going to call outer and inner, or is it going to call both? What's your answer? So what's your answer, friends? In this case? Okay, that's fine. We got some answer here. Okay, let's run this now. Now, but see, what is the output here? We got output of only outer. Then you ask a question. Then how do we call inner, Manoram? Then what do you do? Simple, right? So that is what we have to follow a two-step process here. When you call outer, from outer it is returning inner. Some return type is there. The return type of outer is nothing but returning inner object in inner function. So if you look into the code, outer will finally return this inner object. So if you call inner, then you can have access to inner. So what is that you should do now? If we should call inner, this outer from outer it is returning inner object, inner function. When some function returns a value, what is that we should do, friends? Simple. There are multiple ways to deal this. We'll handle this one by one. Now in this case, what do we do? Let's try to call F1 and see how it works. Run this now. Now you can see now. You got outer and inner. So what's happening here? Outer function internally or implicitly is returning inner. When outer is returning something, we should assign to some reference, right? So we assigned it to reference. Anyhow, it is this return type of this is a function call, right? So what is the return type of outer? It is a function. So if it is a function, we can call that function as like this. We just had discussed aliasing, right? Function aliasing. So F1 acts as aliasing to this inner function. So when you call F1 on top of this, when you apply this caller on F1, this implicitly calls this inner function. I hope you are following this, friends. So this is the idea. So what is it? There are two ways to deal with this. One, you have outer and inner. Outer should call inner first. Okay, what is that outer should do? We should call inner function from outer, one scenario. So suppose you remove this now. Let me just go step by step. This is step one, case one. You understood this simple code, right? How to create outer function and inner, right? Is there any confusion on this? I don't think this is a very simple and straightforward code. And from outer we are returning inner function. Just remember we are returning function, not a value. We are returning object, function object. Remember, friends. If you can ask me a question, Manoram, can we return objects like this? Yes, it's not just values we return. If you wish, you can return objects as well, friends. So that is fine, no problem. Right, next one. Let's run this first. Let's see what's going to happen. Okay, I misplaced one. What do we do? Because once return statement is executed, it will jump back to the caller. That's why when I put caller here, it is of no use. So what should I do then? If it should be useful, put your caller before return. That will work fine. Is that clear, friends? Right now, I just position this caller to which one? Sorry, I'm calling inner. It's not, we should call inner, not F1, because F1, we don't have any function with name F1 here. Call inner. So before return, you call this inner. Now this will work when I call outer, even though we are not extracting this inner object, still we made a call to inner function from outer function. So when we call outer, outer also calls inner so that we get output from both functions. But of course, all this is done by the outer itself. So in this case, of course, this return, if you want, you can use it. Or otherwise, we do one thing. Let's remove this. For now, remove the scenario of returning a function. Now you can see now. Now run this. This time you should get output from both functions, outer and inner. What we are doing, we have an outer function. When we call that, that obviously gets called. And then that inner function, whatever we have inside outer, we are calling it from outer. So that outer will call inner. Then again, control go from here to here and print that inner. And then we get output from both functions. This is one case, right? There is another case, case two. Returning a function as object. So this is very important scenario. This covers what? Case 2 covers returning a function as object. Understand this carefully, friends. Very useful use cases. You can return a value as object. That is a not big issue. But returning function as object is a big issue. It is very important thing. Okay. So what do we do right now? Returning a function as object. How do you do that? Simply, you can see here. Remove this color. If you want, you can have a color, no problem. It's not like if you are returning a function object, it doesn't mean that you should not have a color of that there. If you want, you can keep it. But for our second case, we don't need this because we already tested that case one. Right now, we are not printing inner here. We are not calling inner from outer, but we are simply returning inner object. How to call return that inner function object? Simply just say return that function name. Automatically, the object of that function will be returned back to this color. Is that clear? Now, what is that we are doing? We are not returning a value, but return inner means it is returning a function as object, not a value. Keep in mind, friends. Very, very useful use case. Now, what is that we should do? If you want to get this inner, this what is the return type of outer now? Outer is returning inner. You see, when a function returns some value, you know very well. What is that we should do? This is returning some value, whatever it is. It might be a value, it might be object, or it might be collection, whatever it is. What is that we should do? We have to assign that color. This is the color to some reference, something like some f1 equal to. When we should do this when function is returning. If it is not returning, we don't have any big use of that. Now outer is returning something. And this time that returning something is nothing but a function. So we assign this to some reference f1. And if this is an object and that to a function object, then this is nothing but acts as alias to that inner function. What is this f1 acts as? Alias. Alias means another name to inner. Now I can access this inner through f1 here because f1 is pointing to inner now. Now what you can see the address of this here. See here, friends. I'm putting a cursor here. Just now it is showed us. Otherwise, you can do one thing. Maybe if you want to see the address, why to have that much of problem? Just print inner and see. And here also add one more. Just showing you that this f1 here and this inner object here both are same. They are not different. This is simply acting as an alias to inner function that is present in outer. That's all. Now what do you do? Print f1 here, not inner. Both are same. Okay, let's print it. And you can see here, check here. So function outer dot inner. Just see this one and this one exactly both will be same. You don't have any difference. Why? When you are returning something from outer, this inner is nothing but this one only. The same thing is assigned to f1. Now when you say here, when you print, you can clearly observe that this f1 is nothing but this inner. I hope you are clear. Now when I say f1 like this, what happens now? Which is called by default, this f1 is going to call this inner. Why? F1 is storing the object of this inner function. And when I applied a caller on that f1, obviously this f1 is going to call this inner function. Let's run this now. Now when we run this, you can see now This time you got an output from inner function. But in the first case, first two cases, you are getting output from outer. You can see here. So this is the idea, friends. So case two, what is case two? So case one, we are calling outer and seeing something that we had discussed. When you directly call outer, outer has a direct access to outer function and that get printed. But here we are not doing any calls to inner function inside outer. This time we don't have any call to this inner function. Right. Explicitly we are not doing any call to inner from outer. So then outer cannot do anything. Without call, we cannot call inner. But what this is doing here, outer is simply returning that inner object. So when it returns that inner object, we are trying to assign it to some reference. And on top of that, we are applying a calling so that even inner gets called. So that's why we can see output from inner as well. And at the same time, we got a clear idea. Whatever we are returning here, this inner object is nothing but assigned to F1. And this F1 or inner are same. We again proved that as well. Right? And finally, we also have a clear idea how to return a function as object. We have learned so many things in today's session. We have observed how to pass function as parameter, how to return function as object. There are so many use cases if you just observe clearly. There is so much of learning, friends. So this is the idea about what? Idea about inner functions and the pros and cons, how to return function as objects and how to call it outside this functions, how to call your outer directly, how to call inner through outer. So you can see there are so many scenarios here, right? I hope you are clear on all these things, friends. Is this clear to you, friends? Am I clear or did I confuse you? Can you please confirm in the chat box? Right, this is the idea about the whole bunch of functions. I think we try to cover as much as possible. We have a wide coverage of functions. Almost we did for almost 2 weeks on this function topic. So that itself gives you an idea how much coverage we had on functions, because these are all very important things to know. Now you can answer most of the interview questions without any issues, friends, if you attend on Python. Hope we are good here till this. Right. So we'll jump into the modules topic in next week, friends. And thanks for your right prolonged interest. So and having that to keep going. So what do we do now? So we'll stop this session here. If you have any questions, we might take up. Else, we'll jump to the